In this video, I'm going to show you how to find and use the general formula for the sum of an arithmetic series. So suppose we have an arithmetic sequence which has the first term a1 and a common difference d. What is the sum of the first n terms of the sequence? Well, we already know one formula for the sum of an arithmetic sequence, and it goes like this. The sum is equal to n over 2, the number of terms divided by 2, times the sum of the first term, a1, and the last term, an. Now the thing here is we don't know what an is. We only know what a1 is and what the common difference is. So what we'll want to do in this formula is we want to express an in terms of a1 and the common difference. And that's pretty straightforward. We can just use the formula for the nth term of an arithmetic sequence. And that goes like this. An equals the first term, a1, plus n minus 1 times the common difference. So now let's just go ahead and take this formula and sub it into the sum formula. And then the sum formula will just have a1, n, and the common difference like we want. So subbing that in, we have the sum equals n over 2 times a1 plus this formula here, a1 plus n minus 1 times d. And now we can just simplify. So sum equals n over 2 times a1 plus a1 makes 2a1, and then plus n minus 1 times the common difference. And there we go. There's our formula. Now whenever we need to find the sum of the first n terms of an arithmetic series, we can just plug in n, the first term, and the common difference into this formula, and we'll have the sum. Let's apply that formula to some problems. First, we want to find the sum of the first 26 terms of this arithmetic sequence, 4, 7, 10, 13, and so on. So let's start out by writing out our sum formula that we figured out on the last side. So sum equals n over 2 times 2a1 plus n minus 1 times the common difference. Now let's write this down again, but let's figure out what each of the terms are. So sum equals, what is n? Well, n is just the number of terms we're adding, and we're told that right over here. It's the first 26 terms. So n is 26, so sum is 26 over 2 times 2a1. So what is a1? Well, that's just the first term of the sequence. And we're given the first few terms of the sequence, so we see that the first term here is 4. That's a1. So 2 times 4 plus n minus 1. N we already know is 26, so plug that in. So 26 minus 1 times the common difference. And what is the common difference? Well, we can tell that from this beginning bit of the sequence here. What are we adding to get from each term to the next term? Well, 4 plus 3 makes 7. And 7 plus 3 makes 10. 10 plus 3 makes 13. So on. Plus 3's all the way. So it's really plus 3. Plus 3 is the common difference, so times 3. Let's close our parentheses, and now we just have to compute this. Let's go ahead and do that. So sum equals 26 over 2 is just 13, and then 2 times 4 is 8, and then plus 26 minus 1 times 3, so plus 25 times 3. Alright, so we've done the really easy computations. Let's just stick this in our calculator to compute the rest to save time. So the sum equals 13 times the quantity 8 plus 25 times 3. The result of that is 1079. So there we go. There's the sum, 1079. Okay, so how about the next problem? Calculate the sum from n equals 1 up to n equals 31 of the sequence negative 2n plus 5. So this is really saying we want to compute a1 plus a2 plus so on all the way up to 31, so all the way up to a31, where the formula for an is given by that rule there. An equals negative 2n plus 5. Again, we'll want to use our sum formula. Sum equals n over 2 times 2a1 plus n minus 1 times the common difference. And we know that n here is 31. That's how many terms we want to add, including the first term. So sum equals 31 over 2 times 2a1. Now, what is a1? We don't have that explicitly here. We're just told the formula for the nth term, but that's okay. We can just plug n equals 1 into this formula, and that'll give us a1. So a1 equals negative 2 times 1 plus 5. So that's really negative 2 plus 5, which is just 3. a1 equals 3. So put that in here. And then plus n minus 1. N, of course, is 31 still. So 31 minus 1 times the common difference. And we can pick out the common difference from our formula here. Our common difference is always the number that multiplies the n. It's like the slope of the sequence. So the common difference here is negative 2. Fill that in. Close our parentheses, and now we just have to compute this. So let's go ahead and do that. So sum equals 31 over 2 times 2 times 3 is 6, and then plus 31 times 1 is 30. So 30 times negative 2. Let's just punch that into our calculator. 31 over 2 times the quantity 6 plus 30 times negative 2. The result is negative 868. So there we go. There's our sum. Now let's calculate this sum. It's pretty similar to a problem we've done already, but this time, instead of starting at n equals 1 for the first term, it's starting at n equals 11 for the first term in the sum. So what that's really saying is we want to add together the following terms. We want to add together starting at a11 and then go up to a12 and a13 and so on, all the way up to a42 here. And the formula for the nth term is given by this expression here. an equals n over 2 plus 1. Now what we'd like to do is we'd like to be able to just use our sum formula. Our sum formula, n over 2 times 2a1 plus n minus 1 times the common difference. But this would not be correct because we're not starting at a1 here. This sum formula assumes we're starting at a1, but we're not. We're starting at a11 right here, not a1. So how can we overcome this problem? Well, how about this? Let's write down the sum that's starting at a1 so we can actually use a formula on it. And then let's adjust that a little bit so it actually matches this sum. But first of all, just write down the sum starting at a1. So a1 plus a2 plus so on, all the way up to a42. Now, right now, this doesn't match our original sum here because we're adding some extra terms. We've got a1, a2, all the way up to a10, which was not included here. Here we were starting at a11. So what we need to do is we need to subtract off those extra terms that we've added. We need to subtract off a1 plus a2 plus all the way up to a10. So now this is actually equivalent to our original sum here, because we're subtracting off all of the terms a1 through a10, which will just leave us starting at a11 again. But now the great thing here is in both of these series we're actually starting at a1 now. So we can actually use our formula now on each of these series individually. So let's go ahead and write down the sum for both of these. So this is n over 2 times 2a1 plus n minus 1 times the common difference. That's what this sum goes to. And then minus the other sum. And the other sum we can also use n over 2 times 2a1 plus n minus 1 times the common difference. Now in our first series, n is 42. We're adding up terms a1 through a42. So let's go ahead and plug that in. That's equal to 42 over 2 times 2a1. So 2 times a1. Let's work out what a1 is over here. We know that an is equal to n over 2 plus 1. So that means a1 is equal to 1 over 2 plus 1. A half plus 1 is just 3/2. So there we go. That's our value of a1. So 2 times 3 over 2, and then plus n minus 1 times the common difference. Again, n here is just 42, so plug in 42. That minus 1 times the common difference. And the common difference, we can just look at the nth term formula, an equals n over 2 plus 1. And if we rearrange that formula a little bit, if we write it a little bit more explicitly, n over 2 is just a half times n. So a half n plus 1, and then we can tell what the common difference is. That's just a half. That's the thing that's multiplying the n. That's what the sequence increases by every time we increase n. So we plug in d is a half here, a half, and now we have to go ahead and do the same thing for the other sum. So minus n over 2, this time n is just 10. So it's just minus 10 over 2 times 2a1, and we already found that a1 is 3/2. So 2 times 3/2, then plus n minus 1, n in this case is 10, so 10 minus 1, times the common difference, which we found is a half. And now we just need to compute this. So 42 over 2 is 21, and then 2 times 3/2, the 2 and the 2 cancel out, so we just have 3, and then plus 42 minus 1 is 41, and that times a half is just 41 over 2. Then we have to subtract the other sum. The other sum, 10 over 2 is just 5, and then 2 times 3/2, again, the 2's cancel out, and we just have 3, and then plus 10 minus 1 is 9, and 9 over 2 is just 9 over 2. Let's punch this into our calculator. 21 times the quantity 3 plus 41 over 2, and the result for that, we get 493.5. And now the other expression, 5 times the quantity 3 plus 9 over 2, the result for that is 37.5. And finally, 493.5 minus 37.5 is just 456. So there we go. There is our result. The sum is 456. So now we know how to find the sum of an arithmetic series when we know how many terms we're adding up. In the future, we'll also learn how to solve the opposite problem. We'll learn how to figure out how many terms we're adding up if we're given the sum of the series.